attention. Hello and welcome today. My name is Sarah, and I am the Executive Director here at the Highlands Center for Natural History. And it is my honor and privilege to present to you today our Community Nature Studies Series presenter. But before I launch into that, I just want to express how grateful I am to all of you for being here on such a fine summer day, apparently, when the mission of the Highlands Center is in full swing. Our mission, of course, is to help children and adults discover the wonders of nature and become wise caretakers of the land. Right now we have 40 campers in the field aged 3 to 10. I'm fresh from that field, so I will stand away from you due to my stench. But here you are to contrast that, because learning and connecting with the natural world, discovering the wonder never stops, from age 3 all the way to whoever is the oldest in this room today, in the 90s for sure. So, thank you so much for being here and just demonstrating how important the Highlands Center is and how important our mission is. As we get going, a couple of housekeeping or outdoor keeping items. The restrooms are right outside by the bronze equipoise statue. If at any point you need to use the restroom, you can exit here through the store so that we can minimize the traffic here at the front of the presentation area. We also have a full room, so if you need water or refreshments, just kindly move yourself around the individuals. We have some water in the back. Stay hydrated, it's warm today. So keep yourself attentive, but also safe as you're here today. I want to share a couple of items before we launch in. Today we have 2 incredible books in the Benson Family Nature Store. One is the Geology at the Highlands Center for Natural History, an incredible spiral-bound guide to the rocks and the geology here on trail. We also have Exploring Prescott's Unique Geology by Beth Boyd. And then lastly, but certainly not leastly, we do have Wayne's book here, The Ancient Landscapes of the Colorado Plateau. And yeah, right, I can't do that one arm, thank you. So he'll be hanging out after this presentation if you would like to purchase either of those, any of those. And there's another one by Wayne, Roxanne Wayne, and I can do that one-handed, Carving Grand Canyon, Evidence, Theories, and Mystery. Ooh. Okay. And then finally, I'd like to extend a heartfelt invitation to all of you to join us for an event on April 11th, a fundraiser called Rocks on the Rocks, where 50% of your ticket goes directly towards interpretation, spiral-bound notebooks, and programs associated with our upcoming geology installation in the James Family Discovery Gardens. So please consider joining us in supporting geology and earth science education here at the Highlands Center and the Central Highlands. Okay, now, how many of you have never been here before? Awesome, welcome.
Welcome.
For everyone else, welcome back. And that includes our presenter today, Wayne Ranney. Wayne has been an incredible educator in sharing about geology here in the Highlands in Yavapai County. With a lifelong passion for Southwestern landscapes, Wayne Ranney serves as a lecturer and geologic interpreter on various natural history expeditions and leads trips for Smithsonian journeys and National Geographic across the globe. He is a former professor of geology at Yavapai College, but there is nothing he enjoys more than teaching in an outdoor setting, where landscapes can be observed and experienced firsthand. He has completed about 100 river trips in the Grand Canyon. Wayne is also an award-winning author. I got it. We're going to pick up. Award-winning author who has written for numerous magazines. However, he is perhaps best known for his books, Carving Grand Canyon, Sedona Through Time and Ancient Landscapes of the Colorado Plateau. Wayne lives in Flagstaff with his wife, Helen, and enjoys road trips, hiking, river running, photography, and anything that allows him to get outside in the Arizona landscape. Please help me in welcoming Wayne Ranney.
Wow, thank you very much. I hardly recognize the person she just introduced. It's a pleasure to be back here at the Highlands Center. I've been here before, but it's been a few years, maybe even before the pandemic, I can't remember. But it's so wonderful to see familiar faces and old friends. And I just wonder if those former students of mine from Yavapai College would just raise their hands. A special shout out to you guys because you keep me going. And also to Tom Benson over here, who's one of the founders. Tom took one of my geology classes and said, I'm going to help found a Highland Center here. No, I'm kidding. It was something like that. Anyway, it's a pleasure to be back. My talk today is going to be sort of a subset of my book, Ancient Landscapes of the Colorado Plateau. And although Prescott and the Highlands here in central Arizona are not technically on the Colorado Plateau, they do border it. And I just want to share with you some interesting stories about that. These are some of the Southwest's spectacular landscapes. All of you will be familiar with these kinds of places. And before I forget, these particular layers of rock used to exist here in the Prescott area, but you all moved here too late to see them here. And so you might want to do more research as you go. And there's a few more of the landscapes that we have in northern Arizona, and they are spectacular. But Yavapai County can hold its own. And here's an aerial view looking back over the House Mountain volcano at the bottom of the photograph and the Sedona Red Rocks and the San Francisco Peak. So part of this talk is about Sedona's Red Rocks and that. So Yavapai County, if we just want to focus on that, has some very old rocks. And you'll notice that I've got an abbreviation there, capital G, small a. That stands for giga annum, meaning billions of years ago. So instead of writing out billions of years ago, I do that. Yavapai County also has some young rocks between 3 and 15 million years ago, and the capital M, small a stands for mega annum. So you might see those abbreviations in this talk, and just remember that's what they stand for. The most interesting part of Yavapai County's geology story to me is that this used to be the location of a mountain range just like the Andes Mountains in South America are today. And again, you got here too late to see that, but not by much. It was like this just about 40 million years ago. It has a very rich mineral heritage, which Yavapai County became famous for, and the first Anglo settlers came here because of that, and a wonderfully varied assemblage of rock types. So I do want to say that much of the information that I'm going to present today comes from that book that Sarah was talking about. It's a brand new book, Exploring Prescott's Unique Geology. And I just want to give a shout out to Beth Boyd, who was a professor of geology at Yavapai College for, yes, I don't know, 42, 43 years. And the culmination of all that work led to this book. So that particular book and then the spiral bound geology book Those two are for sale in the gift shop, and if anybody wants one of my books up here, that'll be right here in the front of the room. Anyway, shout out to Beth there. But before we begin, we may have some geology neophytes in the room, and I just want to say to you that one of the biggest hurdles in becoming comfortable with geology is to be more at ease, or at least more accepting of the immensity and length of geologic time. And this is a wall that people run into. And I've got a couple of cartoons here to just joke about this idea of how big time is. Please do not let this be a barrier for you if all of these millions of years seem just incredible. It's actually one of the most rewarding parts about geology, is to imagine how short our lives are compared to the existence of the Earth. And to really put you off of geology, here's a geologic time scale, but of course it's done in a cartoony way with the fossils over there on the left. And I'm just going to show you how many millions of years or even billions of years are shown on here. It's not important that you learn the names of these time periods, and it's not important that you recognize what these geologic eras represent in terms of time. But I will tell you that if you do commit the 4 major geologic time eras, which I've outlined there in the millions of years, it will help you organize your thoughts a little bit better. So just to zoom in on our area, if our country had been divided into states based on their unique geography, we would have 26 states. And you might just look at where you came from before you came to Prescott and just see what state you would live in. You can see there in the lower left, we have the Basin and Range, we have the Colorado Plateau, and we have the Rocky Mountains. And let me just zoom in on that a little bit more. This is actually the modern day landscape of the American Southwest and the 4 corner states. But the Colorado Plateau is 130,000 square miles centered on the 4 corner states. The Basin and Range is one of those 26 provinces that exist to the south and the west, and to the north and east are the Rocky Mountains. The Rocky Mountains, of course, would be the most familiar to most people that don't study geology. Maybe they've heard of the Colorado Plateau, but the Basin and Range, you can think of Prescott as being mostly in the Basin and Range. And these are just some of the famous landscapes. I've got the Colorado River going through the Grand Canyon, and there's Prescott. Now, I will say that there is something called the transition zone, and that's where we're at this afternoon. The transition zone has parts of the Colorado Plateau, but they've been deformed like the Basin and Range. And so here in Prescott, Payson, Globe, those are areas that are part of Arizona's transition zone. And in Utah, they have a transition zone as well on the western side of the plateau. And I may publish a paper. Jeff and Jan might be interested in this. I think we can extend Arizona's transition zone up here to the western part of the Grand Canyon, because in Utah, they have done the same thing. And technically, Zion and Bryce Canyon are in Utah's transition zone. And just to link up the two, I think we could do that. So be going against about 100 years of tradition to do that. Here's an elevation map of Arizona going up to 12,000 feet. Anything between 10,000 and 12,000 are in these white dots here. By the way, did you know that Arizona has 26 peaks that are higher than 10,000 feet? Many of them on the San Francisco peaks. So what is the Colorado Plateau? It's an arid region in western North America. It has a huge amount of colorful, mostly flat-lying sedimentary rocks. And this is where the history of our county comes in from, is from these sedimentary rocks. These are uplifted gently and exposed in cliffs, canyons, and mesas. And these are deeply incised by a few large rivers and their tributaries. If you take any one of those away, you won't have a Colorado Plateau. And in this area just north of Grand Canyon's North Rim, you can see the grand staircase, which is like the layers of an onion getting younger and younger as you march up those cliffs. Now, the Grand Canyon in this view is behind the photographer, and it's also part of the grand staircase. And from the book, Ancient Landscapes of the Colorado Plateau, if there were an imaginary place where the whole stack of sedimentary rocks could be found, you would go from the bottom of the Grand Canyon down here and walk up a 3-mile thick section of rocks. Again, there's no one place where you can see it all, but this is a way to envision what used to exist here in the Prescott area. So if we look at the Grand Canyon, this is the whole depth of the Grand Canyon right here. All of these rocks have been eroded away. And when I used to be a trail guide in the Grand Canyon, I'd be bringing people up the Bright Angel Trail, and we'd be walking 8 miles from the river up the cliffs, and we get to about this spot here, and I'd pull out this diagram, and I'd tell people, be thankful you didn't do this hike 20 million years before. You'd still have to go 2/3 of the way up to the top. And that seemed to help them a little bit, and they could get up to the top a little bit better. When you go to Zion Canyon, you can see which rocks have been eroded off of Zion and which ones are in the subsurface. And yes, the Grand Canyon rocks are still in the subsurface at Zion Canyon. So when the Virgin River begins to cut down a little bit deeper, it's going to go into those rocks. And then Bryce Canyon is at the very top up there in the upper right, which means when you go to Bryce, the layers of rock in the Grand Canyon are in the subsurface and below sea level at Bryce Canyon National Park. This is what you see in Sedona and Oak Creek, and there's Prescott right there. That's what you see, and all of these rocks have been eroded off of the top of the Prescott area, and you just start to see the lowermost layers when you go north on Paulden towards Ash Fork, and you climb up through the Grand Canyon layers. So let's get specific about Yavapai County. Thanks to Harry for sending me some photographs from Beth's book. This is a photograph of Granite Mountain, and you can see that the radiometric age for the granite that's exposed in Granite Mountain is 1.68 billion years old. Another way to say that is 1,680 million. Around the Prescott area, there is also layers of schist. In Jerome, we have the famous copper deposit. This is a Precambrian age copper deposit. It's about 1.75 billion years old. And this is a view looking down Highway 89A just before it enters the town of Jerome. And of course, the beautiful Grand Canyon. Down at the bottom of the Grand Canyon is the Vishnu schist, which is also the basement. This is the bottom of this whole stack of rocks. And there's a couple of other places. If you've ever driven in downtown Phoenix, there's a place on State Highway 51 called the Dreamy Draw. All of you will be familiar with the Bradshaw Mountains. They have these very old rocks as well, and the Four Peaks. So this is our first ancient geography that we're able to detect in Yavapai County. And you'll notice that the land here has no green color in it, and that's because there were no land, plants, or animals this far back in time. Any life that was present on Earth 1.75 billion years ago was in the ocean and single-celled only, like algae and cyanobacteria. Let's just put some training wheels on there for you. That's where the modern-day states are located. And then I'll just locate Prescott for you. And the important thing about this is that these are chains of volcanic islands in every respect geologically. That's just like the Philippines are today, or the Japanese archipelago, or the Aleutian Islands in Alaska. And these little slivers of land are being shoved and pushed into North America. This is the ancient North America. And this real estate will be added to North America. Do we have any real estate brokers in the audience? They always get excited when I mention adding real estate. This is the Vishnu schist down at the bottom of the Grand Canyon. Beth Boyd shared this photo from Highway 69. You can see this muscovite mica that's glinting in the sunlight. And this mica is a very common mineral in these rocks called schist. So the Vishnu schist and the Yavapai schist are the same thing. They were just named separately early in geologic time in Arizona, and so they didn't know that they were the same, and they gave them different names. Bonnie Pranter is in the audience, and I wish geologists would change names. We should just give one name to this schist. You guys would vote for Yavapai. People in Grand Canyon would vote for Vishnu schist. The one in Phoenix is known as the Pinal schist after Pinal County. They're all the same. They all were formed in those volcanic islands that drifted in there. They all have a thing called foliation. I'm looking straight up the cliff here, and you might think of those as sedimentary layers, but they're not. That's actually when the rocks were being formed, they were squeezed like that, and all the mica grains, which are really thin, start to orient themselves up and down like this when the rocks are squeezed. This is a fascinating part of the story to me. These schist rocks have garnet crystals in them. And I've just highlighted those garnet crystals there for you. You can see other ones that were outside where the arrows are. Here's a cluster of garnet crystals right there. This is a botryoidal. That's a Greek word that means bunches of grapes, but you can see these garnets are all growing in there. The amazing thing in this species of garnet forms at specific temperatures and pressures that today are 13 miles below the surface. That tells us that even though the Yavapai schist is exposed on the side of the highway there on Highway 69, there used to be 13 miles of crust that sat on top of it to get it hot enough and under enough pressure to form those garnets. 13 miles of crust was removed. And I see somebody in the back there shaking their head saying, well, where did that 13 miles of crust go? I will tell you where it didn't go. It didn't go to outer space. That means it got eroded off of that mountain range and it went into a basin somewhere to become a sedimentary rock. But since it happened 1.75 billion years ago, those sedimentary rocks are gone. The garnets are the key to understanding how deeply buried these rocks were. And here I'm going to show you how rocks that were 13 miles down come back to the surface. So when these volcanic islands are drifting into North America, they squeeze the crust horizontally and the crust gets thickened vertically. This happens all the time in all of the Earth's mountain ranges. You can see how it's been shortened horizontally and thickened vertically. So compression grows the mountain upward and downward, and I have a yellow dot there in the middle that shows you how rocks that were once 13 miles down get back to the surface. And the dotted lines show you where the mountain range was before all of that erosion. When you remove the confining weight of the mountain range, the root of the mountain pops up and brings these rocks back to the surface. That's another neat thing about geology is all of this is common sense once you get exposed to how the earth works. So I have these maps that show you the incremental origin of the Yavapai schist. A long, long time ago, there were a bunch of microcontinents that were drifting about independently. And at about 2 billion years ago, they all came together. And where they smashed into one another, we've colored in brown here. And these are the collision zones of these microcontinents as they came together. So when you date these rocks in here, they're younger than the rocks that formed the core of the old continent. Now regarding the Yavapai schist, we've colored these in green, and all of these volcanic islands that came in were sequentially added to the southeast side of North America. You can see how the colors get lighter and green here. And geologists have dated the rocks, And you can see the Mojave province 1.8, Yavapai 1.75, Matazel 1.7, 1.4, and 1.0 there. We are really adding real estate to North America. And everything colored in blue there is stuff that has only arrived in the last 200 million years. California did not exist, Oregon, Washington, they all came in. Regarding the granite dells, that's a slightly younger granite body than the granite mountain. That's 300 million years younger, or 1.4 billion years in age. And another photograph from Harry. People always wonder how these rounded rocks of the dells form. And if you look at this, you can see these fractures that are running at various angles through the rock. Water can get in there and start to erode away the feldspar crystals, and the edges of them get rounded off, and then you're left with something like that sitting on top of the boulder. Non-geologists go by and wonder who put that rounded rock up there, but really they're just rolling down once they become eroded, and then they sit on the surface down below. So these rocks are already eroded away, but they're not forgotten. You cannot see them in the Prescott area, but very quickly, let me just show you some of the wonderful things that used to be here. These are the top 6 layers of the Grand Canyon right here. And just to remind you, sedimentary rocks leave a record of the landscapes in which they formed. And so when we look at the very bottom layer that is exposed just north of Paulden, this was the geography of the Southwest at that time. And this is essentially the Pacific Ocean, but the edge of the continent is right at the edge here where this light blue color meets the dark blue color. So the edge of North America was flooded by seawater. There's Prescott right there. And this is the continent here, also before any vegetation was growing on land. If we move up to 340 million years ago, there's a layer called the Red Wall. Many of you have driven by the Drake cement plant on Highway 89, and they are mining the Red Wall limestone to make cement. Look at how extensive the continental shelf was in North America. All of this is ocean water, and it's just flooding most of the entire surface of Arizona. And then we jump up to the age of dinosaurs. This is the same geography. You can see the 4 corner states there. The red dot is Prescott. And there was this ancient river system that made its way from West Texas on up to the edge of the continent there in northern Nevada. And the evidence for all of this comes from the sedimentary layers. This is the Chinle Formation in Petrified Forest National Park. And geologists and graduate students studying layers like this can tell us these are river deposits. The fossils that are within them can tell us what the climate was and what the landscape was. Here's a piece of petrified wood with a branch that was growing out of the tree there. And this artist has drawn what the Highlands Center looked like 215 million years ago. And there we can see the mountains that were present to the southeast, and the rivers were coming out onto these floodplains. And everything that you see in this drawing right here is from fossil evidence that has been taken from the Chinle. There's a phytosaur over there in the lower left. You can see a Coelophysis dinosaur down below at the center. You can see Equisetum growing up, and then there's the trees that eventually became petrified. People often ask me, they say, Wayne, when you drive to petrified forest, do you imagine that? And the answer mostly is no. I'm looking at the modern landscape and getting inspired by the modern landscape, and having that geologic story in the back of my mind makes the modern landscape come alive better. So don't think that you have to understand the ancient landscape to be a geologist. What this ancient geology is doing for me is bringing the modern landscape alive. And I'll just give that to you as an indication on how you can drive through the landscape. At 180 million years ago, everything turned into a Sahara desert. And all of this here is windblown sand in a rock unit called the Navajo sandstone. It is the largest fossil desert that we have a record of on the globe. And there were sand dunes all over the area, just like this. This is the Navajo sandstone in the Echo Cliffs area. And here's somebody walking at a place called Coyote Buttes, and you can see the leeward side of sand dunes there. Those are lithified sand dunes right there. Those are the backside of a sand dune. And this is a spectacular place to see the Navajo sandstone exposed. So now we get to what I think is the most interesting ancient landscape in Yavapai County, and that is that the landscape we live upon today has been inverted from what it was 70 million years ago. If you were here 70 million years ago, you would drive down towards the Phoenix and Tucson area, and you'd be climbing up into high mountains. And if you went north to Flagstaff in the Grand Canyon, you would drive down to sea level. I don't think I need to tell you that it's exactly the opposite today. The landscape has been inverted. And the idea is that there was an ocean plate here that's now mostly underneath the continent, but it was drifting into the edge of North America and being shoved under it. It created a line of volcanoes. That's this Andean type mountain range that used to exist here. And this is a cross section of the same thing. So in this ancient landscape, Prescott was located just about here at the foot of the mountains. And right over there where the Colorado River is today, this would have been where this trench was formed and the ocean plate going down. Here's the paleogeography from 90 million years ago. This is when the sea was last close to Prescott. Prescott's located right there. You would have only had about a 75-mile drive, and you could have gone to the beach right there. But look out for the dinosaurs because they were there. They're zooming in on that right there. It's called the Western Interior Seaway. Here's some of the dinosaurs you would have found on the coastal area. This particular painting was done right on the shore in the swampy areas just back on shore. So here we are at about 70 million years ago. You can see the Western Interior Seaway is beginning to recede. This predates the Rocky Mountains. The Rocky Mountains have not yet come up in Colorado, and I want to draw your attention to our area down here in Yavapai County. There's the training wheels for you. And if we zoom in, we can see where Prescott was located. And that ancient mountain range has been given the name by geologists, the Mogollon Highlands. Now I know the word Mogollon Highlands is used often for the Prescott area today, but this is actually a geologic term that was invented back in the 1960s to describe this mountain range that nobody ever saw, but we have evidence on the landscape that it used to be this way. And again, when you look at this, you can see how you would have driven to the north and come onto a coastal plain and driven to the south and gotten into the high mountains. And this is the way that the rivers went at that time. And all the dinosaurs were living down there on that coastal plain. They were probably here in Prescott as well. But remember, the rocks have been eroded away completely from here. And so you will never find a dinosaur fossil unless Sarah plants one out in the garden out there for the kids, and they can find a dinosaur fossil. Now, believe it or not, the South American continent today is a perfect modern analog for Arizona 70 million years ago. And today, this other ocean plate called the Nazca Plate is being shoved under the edge of South America, and it's creating the Andes Mountains right here. And then there's a big coastal plain right here. So if we just turn South America a little bit like that, and then change the names to the Farallon Plate, the Mogollon Highlands, and the North American Plate, we can look at that modern setting and then put the Amazon River in there, flowing out to the Atlantic Ocean. And this is a perfect modern analog for the geology of Yavapai County 70 million years ago. That's why I think this is the most incredible part of the geologic story. So here's a cross section from south to north from Beth's book. And you can see how Prescott is sitting right here on a surface of the Precambrian rocks. And when the Mogollon Highlands were uplifted, it tilted all of the layers so that they're tilted down. This is the Grand Staircase right here from the bottom of the Grand Canyon up to Bryce Canyon. And Sedona and Flagstaff are located there in the Mingus Mountains. That's a fabulous cross-section from Beth's book, and it was the uplift of these highlands that tilted these rocks and precluded all of you from seeing the sedimentary rocks here. So just to talk about the basin and range and the transition zone, they have formed exactly where the Mogollon Highlands used to be. And it began about 20 million years ago. And 20 million years ago, the crust of the earth began to become stretched such that the Mogollon Highlands were faulted down and destroyed. The topography became inverted, the rivers reversed their flow direction from north to south, and crustal thinning caused a lot of the volcanism that is present on the surface of Yavapai County. There's so many volcanic rocks here, and this is all part of the crust being thinned in the destruction of the Mogollon Highlands. And this is an aerial view of Perry Mesa. Interstate 17 would be just off the left side of the photograph there, and we're looking to the northeast. Perry Mesa is a great big sheet of lava that was erupted between 10 and 15 million years ago. Here's a view of the same thing from Black Canyon City, looking up to the northeast. When you drive down the steep hill after the Sunset Rest area, you go right through these lava flows, and they were active between 10 and 15 million years ago. So now we're looking at a paleogeography here beginning about 20 million years ago, where the Mogollon Highlands have been destroyed and the western side of North America is being stretched east and west. And to cut to the chase, it's really the San Andreas Fault over there in California that is causing the extension in the basin and range. And I want you to look what I've superimposed on this diagram right here. This is the direction that the two plates are moving. We have the Pacific plate off to the left, the North American plate to the right. They're not exactly moving exactly away from one another, but they're moving in different directions. And when the arrows start to move, watch the San Andreas Fault rip through the landscape. Right like that. And so one day Los Angeles will be opposite of San Francisco, and the Dodgers and Giants will be crosstown rivals once again. I don't know what Sarah Palin's going to think when all those Californians arrive in Alaska. So all of this purple area here has been stretched out 100%. In other words, the Sierra Nevada mountains, which you see right here, used to sit in eastern Nevada, very, very close to Arizona. But everything has opened up and widened here in the last 20 million years, and that's when the landscape became inverted. And here's the modern day landscape with the Colorado River flowing through it. And that is a mystery on exactly how these rivers got turned around, because a lot of it's been eroded away. Just to show you some of these volcanic rocks, this is Glassford Hill. That's a typo there. I meant to type 13.8 million years ago. That's 100,000 years, so that's a significant amount of time. I should put 13.8 in there. And this is also from Beth's book. You can see that the Glassford Hill volcano was erupted out on top of paleotopography. All of this area over here is the Granite Dells granite. Here's the center of the volcano. It erupted right at the foot of this old cliff, and the lava flows could only go out in 3 directions out of the volcano. That's why when you look at Glassford Hill from Highway 89A and look back, you don't really see the shape of the volcano like that view right there. And here's another great picture by Harry looking on a nice summer day back to Thumb Butte. Beth did original research on Thumb Butte. It was very confusing on what Thumb Butte is. Is it a lava flow that's just got a remnant left? Is it a volcanic neck? And she was able to determine that what she thinks it is a vent concealing flow, meaning that the lava was coming out of the ground very close to Thumb Butte. When it got to the surface, it started to roll over and become a lava flow. And what you're looking at is where the vent was to issue the volcanic rock, and it started to spill over into a lava flow. We all got here too late to see the lava flow that used to surround Thumb Butte. Now, for my master's thesis, I mapped a very similar thing to Glassford Hill, and this is a photograph from a friend of mine. This is called House Mountain there in the lower half of the photograph. And let me just show you what I was able to map is that this volcano erupted at the foot of the Mogollon Rim about the same time Glassford Hill was active here. You can see where the Mogollon Rim is located today, but 15 million years ago, that rim was located right here, and this volcano erupted at the base of that ancestral rim, and the lava flows could only go out in 3 directions from here as well. And what's happened in the last ensuing years is that the Mogollon Rim has eroded back farther where uptown Sedona is located and created this valley here. And I'll never forget when I came up with the conclusions for this, there were so many geologists that had a different story about House Mountain volcano. They weren't sure that this young kid could talk about that, but nobody had ever mapped it in detail. You have to map things in detail to see what's really going on. And I'll just leave you with one last great story from Yavapai County, and that is the fact that in the Verde Valley, between 9 and 3 million years ago, a basin and range basin had opened up to create the Verde Valley, and these white limestones where Montezuma Castle is located were deposited in a freshwater lake. And if we look at the area of the Verde Valley, there's Interstate 17. You can see the towns around there. And here is the lake when the climate was wet during this 6 million year period. And these white limestones today are completely enclosed in the Verde Valley. They do not extend beyond the Verde Valley. But occasionally the climate would dry out. And when it dried out, the lake would become much smaller and became this saline body of water full of salt and gypsum. And this happened multiple times. When you look at the layers in the Verde Formation, you see white limestone, red mudstone, white limestone, red mudstone. And this is the lake expanding and retreating as the climate is changing through 6 million years of time. Here's the famous salt deposit near the town of Camp Verde, and in the 1920s, the Morton Salt Company actually had a mine here for domestic salt. There's another close-up of it, and there's some great minerals that are found in here for those of you that like minerals. I want to show you this. This is a photograph. I was out on a field trip with the U.S. Forest Service. This represents a moment when the climate was wet. You can see the white limestone here, but where the trees are growing, you can't really see it, but it's red mudstone in there. Where did the red mudstone came from? It came from the streams coming out of the Sedona area and filling in the edges of the lake. Well, the reason we were out here is because there's these fossil trackways, and this is a bed within the Verde Formation that's about 4 or 5 million years old, and there was an extinct species of wolf that left this trackway. We also found a trackway of camels, ancient camels that used to live here, and a stegomastodon, a giant elephant. And when you look at this footprint here, this is the front or the back of the foot here. You can almost imagine that limey mud squishing when the elephant walked on the lake shore. You could hear it pick up its feet and hear that suction as it was coming up there. Now it's solid rock. And we could also see where the elephant and the wolf had crossed each other. You can actually see the trackway of the elephant there. And then in the year 1980, NAU geology students were out at the Clarkdale cement plant, and the woman in the red sweater there had found a piece of ivory the size of your thumbnail and took it to that man with the hat on. That's Dr. Larry Agenbrod. He was the elephant expert for North American elephants. And his blood pressure rose. He said, "Where did you get this?" And she said, "Over there." And they went back, and the next week they came back, and they actually dug out the lower jaw of a stegomastodon that was in the lake beds. That's all that was there, was the lower jaw. And the teeth are down in the ground. The jaw is upside down. And those are 12-foot long tusks that go out from there. So you don't have to go back hundreds of millions of years ago to enjoy these ancient landscapes. We actually have evidence from just 4 and 5 million years ago. And then an artist at NAU came up with one of these paintings with all of the trackways and the fossils that have been found in the Verde Formation. This is a little bit, how shall I say, gentrified. I mean, these animals weren't that close together, but we got jaguars, we got horses, we got the stegomastodons, we have camels. Somewhere in here are some birds. There's a great big bird right there. More camels over there. So these are some of the ancient landscapes. And I hope you enjoy this right here. I'm just going to show you the entire globe through time. There you can see the Highlands Center with the red dot. There's a present day view of the globe. And 50 million years ago, you can see that Europe was a series of an archipelago right there. We didn't have the collision of the continents yet to form that. 90 million years ago, when the Mogollon Highlands were present, 170 when the Sahara deserts were in our area, 200 million years ago. By the way, the colors do reflect climate. Green are humid areas, and the earth tones are the dry areas. 260 million years ago, we're getting closer to the equator. And 340, when the cement material from the red wall limestone was being deposited, we were actually in the southern hemisphere. And there's 540 million years ago. So this is the landscape that we all get to live on today. This is a view from Yarnell, from the Hot Shot Trail. And of course, Sedona's lovely red rocks, which are definitely part of Yavapai County. And I've been fortunate enough to do guide training for the guides at Castle Hot Springs. I'm not going to pay $2,500 a night to stay there, but I will go stay there when they let me, and I get to do that. So anyway, if you want to take some of these stories home with you, you can go to the bookstore and get Beth's book, or right up here, I can get you Ancient Landscapes. I do want to say a couple of things, because I know the question comes up, Wayne, why should I care about this? And I get it. I mean, this is like somebody who's passionate about baseball cards. Other people look at that and they go, "Oh my God, that's an odd thing to be interested in." But I do want to say that, you know, I'm in my 8th decade now, and I'm starting to realize that most of my life has already gone, and I'm looking, you know, towards the end of life, and I get a little bit philosophical about that. The one thing that helps me is understanding that all of this has been going on for hundreds of millions of years, and there's every indication that it's going to go on for hundreds of millions of years in the future. And for me, that is my comfort. And I know that for a lot of people, there are religious traditions and spiritual traditions that do the exact same thing. They make us feel comfortable about our own mortality. And this does that for me, and it can do it for you. And I'm not saying it needs to take the place of anything else you're doing. It's just another additional thing. And thank God for these ancient landscapes. I'm happy to take some questions. Thank you. Are there any questions? Yes. Good. Nice to see you again.
There's a event in geologic history called Yavapai College. Talk a little bit about that.
Yeah, the question has to do with an event known as the Yavapai orogeny. And if this were a geology class and we were all taking it for a grade, I'd have to use that term. You did hear about the Yavapai orogeny in this lecture, but I didn't use that term. An orogeny is a mountain building event. The word "or" comes from that root word. And the Yavapai orogeny is what created the Yavapai schist. So when these volcanic chains of islands were drifting to the north and adding real estate to North America, that was the Yavapai orogeny. And on top of the Yavapai schist, there was a gigantic mountain range, and there was 13 miles of material that used to sit above the rocks you walk on today. And the erosion of that mountain range was the tail end of that orogeny. So you have obviously been exposed to a little bit of the geology of Yavapai County, and that's what that refers to. So the Mogollon Highlands were also an orogeny, and we call that the Laramide orogeny. It was named after Laramie, Wyoming, where a basin had a bunch of sediments from the mountains that were being uplifted in that orogeny. Yes?
What's the age of Thumb Butte?
The age of Thumb Butte is about 13.9, if I'm not mistaken. Is that about right?
Same age as Glassford.
Yes.
Slightly older.
Tiny bit older. Thumb Butte is tiny bit older. So my 13.9 date, I might have been thinking of Thumb Butte. But the important thing to remember is that most of these black basalts from the Sedona area to Glassford Hill, and then all the way towards Phoenix. When you drive on 69 and I-17, you're driving through a section of basalt lava rocks from a volcanic event that happened between 10 and 15 million years ago. And when you're in the new flex lanes and you're driving down to Phoenix, you see the road cuts. That black gray rock that you're seeing there are all lava flows that were active during that 5 million year period. Yes?
Expanding on that, what triggered the volcanic event?
What triggered that volcanic event? So as you go to the southwest from Prescott towards the Baghdad area, the basalt lavas down there are slightly older than the ones in the Sedona and Prescott area. And then you finally get to the Flagstaff area and Williams, and the oldest ones there are 6 million years old. So there's an age progression of this basaltic volcanism from the area near Baghdad all the way up to Flagstaff. And the most recent theory is that the bottom part of the Earth's crust is detaching and slipping down into the Earth's mantle, and hot material is coming up to replace where the bottom of the crust used to be, and it's bringing hot rocks very close to the surface. And since the crust is being stretched and thinned, that magma can find its way to the surface progressively. So it's almost like you're delaminating the bottom of the crust from the southwest to the northeast. And if you live to the northeast of Flagstaff, stay tuned. There's probably going to be more volcanic eruptions in the near future. I don't think you have volcanic hazards in the Prescott area, but there's no guarantees in geology. Yes?
So Mogollon is the Spanish governor?
Yeah, Mogollon was a Spanish governor from 1712 to 1715. So it was still part of New Spain. And Juan Ignacio Flores Mogollon sent parties out this way to explore for mineral wealth, and came on top of the Mogollon Rim, and that name has been applied since that time. Yes?
Well, so philosophically too, as you were saying, so I can have dollars to maps and how fast the icebergs are melting. But, so all of this is happening fast.
Well, on the one hand, I'm very glad you brought up that comment, and it's also very difficult for me to talk about it because the comment was, she has solace with climate change and what we are experiencing on the planet right now. I mean, it's more than 100 degrees in Phoenix today in March. I think you'd probably have to not be paying attention to see that the climate is warming and that we are headed into a different climate period. But if you hang out with this geology long enough, you realize that the main message in all of this is that things change. And you know, when we were all born, we were given a chip for geology, and it was made in China, and it's not very powerful. It's like the batteries you get with your electronics. They don't last very long. So what you do by coming to a presentation like this or taking a geology class at Yavapai College is you upgrade your chip. And by upgrading your chip, you realize that the whole message is change happens. And we have to get over that. Now, as it regards climate change and what we're doing now, you know, that's a very real threat that possibly humans can deal with. My opinion is it'll be very expensive to deal with it, but, you know, we could deal with it, but all the critters that live out there, they're going to have to deal with it too. They have dealt with it in the past because the climate has changed in the past, and in some instances it changes really rapidly. And there are winners and losers in every geologic event. So I have solace too as it regards climate change, that I recognize that whatever we do, the earth will come back. But I also feel bad that we might be causing it and that we are having an effect on it. And I do whatever I can. I recycle my glass and walk downtown when I can. I mean, I do what I can because that makes me feel good. So I hope that's a long-winded way to say geology teaches us that change is natural. Our economic and agricultural systems are not set up for rapid climate change. So I worry about that. Yes, in the back. Oh, the San Francisco volcanic field, yeah. Up there at the San Francisco peaks, that used to be a conical volcano until about 500,000 years ago. And the top of it collapsed. It didn't explode, but it collapsed. And it probably was 2,000 to 3,000 feet higher before it collapsed. But it wasn't a supervolcano. Whoever told you that was mistaken. A supervolcano is a much larger eruption, a much bigger in area eruption, and a much more powerful eruption. The peaks grew to their height over about a 2 million year period, and it's only in the last 500,000 years that the top collapsed. And it's a normal stratovolcano like Mount Rainier or Mount St. Helens or Mount Fuji or Pinatubo. There's lots of stratovolcanoes on the planet. Yellowstone is a supervolcano, and that last erupted 640,000 years ago. In the back.
I'm fascinated by the Verde Lake. What dammed it up? Was that House Mountain lava that created a dam? And when did that, how did that dam go away? So the lake is long there.
Yeah, what created the Verde Lake? When I was a neophyte in geology, there was a theory that lava eruptions from the Hackberry Mountain, farther south of Camp Verde, created a lava dam that caused the water to back up of the Verde River and create the Verde Lake. But since I was a neophyte, the understanding of the lava dam story has been much more advanced. And it is true that these lava flows can dam rivers and dam them in a big way, but those dams are very short-lived, on the order of hundreds or thousands of years before they become destroyed. So the idea that a 6 million year long lake could be encased by a lava dam on its southern end is no longer tenable. It's the idea that the Verde Basin was actively subsiding and creating the space for that sediment to become preserved. And those of you that used to be in my classes, you will recall that all those layers of sedimentary rock are not only a record of past geographies, but they're also a record of how the crust was subsiding to create the space for that sediment to be preserved. You can wash sediment into a basin, but if there's no place for it to park, it has to go to a place where it can park. And the only place it can park is where basins are actively subsiding to create the vertical space for it to park. So when we see this 3-mile stack of rocks on the Colorado Plateau, that's also a record of crustal subsidence through a 400 million year period to allow 3 miles of sediment to accumulate. And that's graduate level material that you did not pay for today. Did you have a question, Mary? Okay, okay.
Why is it that we only have one meteor crater? I think that we have a variety. Every state should have a meteor crater. Can you speak to why that is unique and what events might transpire to make another one?
Well, it's pretty well understood that the reason we don't have more visible meteor craters is because the Earth is tectonically active with an active atmosphere that destroys evidence for craters. You don't know the current number because they're discovering craters or evidence for craters pretty much all the time. But the last time I looked, there were around 200 known meteor craters that can be detected. They might not look like meteor crater, but you know, if they happened 500 million years ago, there might be a tiny bit of evidence that tells us that was a meteorite that hit. There's only about 200 of them, but when we look at the moon or Mars, they do not have active tectonics that is destroying the crust, and they do not have active atmospheres that can weather the crust. So it's really just a function of us living on a planet that's alive, and it destroys the evidence for those craters. Yeah. And another reason is meteor crater only came down 56,000 years ago. And I want all of you to go out of here to say only 56,000. Only 56,000. Oh, that was yesterday. Yes, again.
Well, this is a silly question. Why is Castle Hill Resort so over the top?
Well, it's the oldest resort in Arizona. It was established as a resort in 1896, and people have been going there ever since, although there was a long period of time, almost 50 years, when a fire destroyed it and it was not open. But the reason it's so expensive is because there are people who can afford to go there. And this delves into the topic of capitalism, which I'm not qualified to talk about.
One question, you mentioned that there was like 13 miles of erosion. Is that the same time period as the Great Unconformity?
Oh yeah, that's exactly where the Great Unconformity is. So when that 13 miles of crust was eroded away, there was an undulating plain created on top of the Yavapai schist, and these sedimentary rocks came to rest on that 1.2 billion years later. So it was half a billion years ago that this sediment pile started to pile up, but the Yavapai schist was already 1.2 billion years old, and it took that long for 13 miles of crust to erode away. So that is the Great Unconformity. Anyway, I'll be up here to sign books or answer personal questions. Thank you so much for supporting. Thank you so much for supporting this institution. And they did not charge you for this. If you want to leave a donation, I think that's a good idea. Thank you.
Before you get inundated.
Yeah.
Connecting the Western